Tigerfest 2018 has begun. Several tigers looking for attention. But our main patient at the moment is a lightning victim. This poor amp suffered boldly. Kurt has rebuilt the boards, pretty much all the transistors. We did find a few transistors that survived the lightning strike, but they're all gone. Switch them all out. So we're just about ready to start testing this thing and see if we can get some life out of her. And we're not using my crappy dim bulb tester. We're using the Fester tester. So we're getting ready to test the Frieger, the fried mini Tiger here. 215. What'd they call this? That's about all they called it, huh?
Yeah, all it had was a number, no name.
So
the amp was no name.
We've got the Variac all the way down. We've got it on. I think the Tiger is on. The Fester tester is on, I think. Yes. So everything's on except for the Variac is down. I'm monitoring current across, idle current basically. I should be able to see the offset on the scope, which you can't see right now. We're about ready to test this bugger. Oh, I lost my clip. And I want to see my input real quickly. Yeah, there's a signal there. Somewhat of a signal. It's very small. Just what I want. Alright. So I'm going to be very brave here and see. Nothing happening. What do we got off here?
The Tiger probably? Or I don't know.
Is this plugged in? Yes. Oops. Oops.
Must apply power.
Okay, so we're going to try this again. You're slowly cranking. Oh, we got a sine wave on the oscilloscope. Off screen, unfortunately. Our current looks good. Idle current is staying in control. Of course, we only want this to get up to 5 millivolts. Why am I didn't really want to do that. Should have left it automatic. I don't know where I am now. And it's looking good. We've got output. I am going to swing you at the output real quickly here. So it looks like we got a possible victory here. And my idle current is pretty good. And my kitty's playing with something in the background.
She's scavenging under a bag.
Charles, what are you getting into?
There's a bag on the ground and the cat is digging under it. He's sticking his nose under to see what's there.
Okay, now I'm going to crank the voltage all the way up and see if we get smoke.
Keep the smoke in the amp.
We're doing good. We got 0.3, a little bit low on idle current. Not terribly low, though.
Just went up. Up, down, up, down, up.
Yeah, actually, we've got to get it warm before we even look at this. This is probably not going to need anything with that 100 ohm resistor we got in there. We got 100 ohm resistors instead of the pots in this unit due to a long-ago modification or long-ago rebuild. I guess I wanted to make it bomb-proof, so I...
Kurt-proof. Kurt fried this before. We're not letting him do it again.
Yeah, we're probably just about right for being cold. That's probably perfect.
Well, we can live with it if it's if it's a little low. That's just cool,
So fine. We're looking good so far.
And I'll throw my pot in so I can break it later when I get home.
And success. We have the other side of the Tiger, other channel. This is 215 mini Tiger, and we're getting signal in and out. We've got our idle current in control. It's quite cold in this room. It's probably about 60 degrees. So I'm going to have to let this amp get nice and hot, probably cover it up a little bit. Oop. That's not working. Get nice and warm, make sure that this stays under 5 millivolts. Right now we're at 0.9 millivolts, so we're good there. All right, looks like we're healthy on both channels.
Yes, yes, yes.
Kurt succeeded to what had to be a lot of work to tear that PC board apart and back together again. Replaced all those electrolytic, didn't replace the electrolytic, did you?
I replaced the electrolytics, and
Oh, good.
I also a few burned out resistors,
And several
pretty much all the diodes, all the transistors,
That's what lightning will do for your day.
and the output transistors are new as well. So.
Most of those were fried too. At this point, we've checked both channels. Both channels seem to work, except we're getting some voltages that are not right.
Well, you know what?
We go on our schematic, and instead of getting these 14s, we're getting what climbs up to 19. Well, climbs up above that. I put a this diode here, this Zerner, is what actually pulls this whole front end voltage down, and it's supposed to be a 36 volt Zerner, and clipped right across the Zerner on either channel, it goes all the way up to almost 40 volts. So we either got the wrong Zerner or we got defective Zerners. And here's the Zerners he put in, and it says 36 volts right on the tape.
And we actually have some that I bought previously, so we probably have the opportunity to fix this, even if those are wrong.
Okay, we'll test both. We'll test one of each is what we'll do.
Yeah.
And then we'll see how they do. Because right now everything works, but we got too much voltage. I don't want to release it that way because it'll, if nothing else, it'll make the front end noisier than it should be. But in terms of,
Your video.
well, an interesting little test. We had too much voltage on the input sections of these. We grabbed the diodes from the source that he had. He had a whole kit. Is these those he used?
Yes.
He had this really cool kit. All these voltages, and they're all labeled nicely. Really cool kit. Unfortunately, when we put the Zerner diode to test, we got one of the same ones he used in here. We put it in series with the resistor, 4.7K resistor, and we have it across the whole power supply, which is 65 volts. And this should carve out 35 volts out of that 65 volts. Well, we checked the cheaper brand. Really beautiful packaging. Sweet. Chinese confidence here. Unfortunately, they don't measure 36. They measure like 39 or something. And then we put the real ones that he got from a respectable place like DigiK or someplace. I'm not sure where he got them. But he got them from a respectable vendor, and surprise, surprise, these ones measure correctly. And even the leads are much stiffer. It's like these ones, the leads are like putty. And these ones, the leads are really stiff. So it's just another time to be aware of Chinese components. Test, test, test. Don't rely. And unfortunately, that's bad because this is such a nice little kit.
Well, and I'm very curious if we could use say the 33 volt. I intend to use my Vishays here, but I think we ought to test a 33 volt and see what that gives us, just for curiosity.
Good, just for yucks. But it's a warning to all the young players about Chinese components. Stability, who knows?
And even worse, Kurt will fry it.
And now I've got the amplifiers running close to full output. I should actually back it off 50% if I want it to get really hot fast. Half output actually gets you warmer faster. But I've got it covered up under these paper towels just to get it warm. And it was in the 110 area, about where I want her. Yeah, 112, 110. So we're close to where we want to be for temperature. So I've got the amplifier hot by running it, kind of obstructing it, getting it nice and hot. And what I want to check is the bias current on both sides. So at this point, I am just going to kill my input signal carefully. I'll switch the unit off, that'll work. And we look to be a little bit low on our readings for idle current. I'm going to have to do some double thinking here, make sure I'm doing what I think I'm doing. I'm on the 0.1 ohm resistors. Let's make sure I am where I think I am, I guess. I think I'm on R39. That should work. Actually, R37 should work as well. The full current of the supply. Not making a very good video here. Oh well. It's going to be a little bit of a... We're just about ready now to see if we can get this guy purring. Didn't say it very well, did I? Edit point.
It sounded sufficient.